Hello viewers, this is Anand from Tech My Style with another video. Today I am going to go over the design of a fun project that I am working on, a digital RGB clock using non-addressable LED strips. I have some non-addressable LED strips lying around and I don't want to use this just for decoration. Instead, I want to create something cool and useful with it. What we have here is a 1 digit of the clock. I have built a total of 4 blocks like this. This is how I approached building a digit. I took 2 LED strips with 60 LEDs per meter and cut into individual pieces of 3 LEDs each. I have aligned them in a way that I see the same color on the outermost line, which is blue in my case. This way I can easily connect all the RGB lines of all the pieces and feed the color from one end. I haven't connected the VCC lines here as I need control over the individual segment of the 7 segments. Now to control the 7 segments, I have attached a shift resistor 74HC595. I have attached a 8-pin female header through which I can feed in power, VCC and ground lines, red, green, blue signals, and 3 pins to control the shift resistor, which are data, clock, and latch pins. With this design, I can easily daisy chain how many ever digits I want and control them with just 3 pins of the shift resistor. This digit can be controlled using an Arduino, but I want to provide the ability to change few aspects of the clock, like changing the color or brightness or starting a countdown timer or anything that we can do using 4 digits. Do you have a suggestion on a cool feature? Please leave a comment below. My idea is to export the RESTful service call with which I can interact with the clock, so I was considering either ESP12 or Raspberry Pi 0W. I went with Raspberry Pi 0W as it's easy to code using Python and Flask and easy to connect and change in future just by connecting through SSH. I did encounter one problem with the RPi. I need 3 PWM lines to control the color, but RPi has only one hardware PWM pin. I have tried using 2 soft PWMs to compensate, but the LED started blinking instead of showing a smooth color. To overcome the problem, I have attached a teeny tiny 8085 just to control the color. Now that I introduce another challenge, how do you change the color or brightness? Now we need both the RPi and the 80tiny to talk to each other. Luckily, this was surprisingly easy via a soft serial communication. Now it's the demo time. To illustrate that this setup works, I wrote a small program which displays 0 to 9 and changes the color for each digit. That way, we know that our hardware works and the communication between the RPi and the 80tiny. Here we go. We are counting 0 to 9 and changing the color. So it works. I have created a cheap styrofoam solution to diffuse the color. I have also built this board to get rid of all these wires and snap in the boards easily. The next step is to put this all together and secure it nicely. It may seem like a lot of effort as I have used non-addressable LED strips. I did it because I have the strips, not that I want to build a clock and then bought the strips for. If you have plans to build a clock, I would definitely recommend getting addressable strips so that the build is much simpler. You don't need as many pins and don't need 80tiny either. From this video, you either gain knowledge on how to do it or more reasons to not to do this way. Either way, I'm happy. Thanks for watching and see you in the next video.